In order for chemical reactions to occur, molecules need to collide into each other. This has been looked at, and they call this collision theory. This is the topic of Screencast 13.5. We'll consider what three things are necessary for a chemical reaction to occur. Maybe you can think of more. And, well, how effective is this theory? How useful is this theory? Is it useful for predicting the rate of a chemical reaction? Maybe you can think of some reasons why it is and why it isn't useful. Okay, let's begin. How do molecules react? Well, they have to, number one, collide. Number two, they have to collide with enough force. And number three, they better hit at the right locations for the reaction to take place. A possible exception could be a decomposition reaction, but even then, it may be two substances combining, hitting each other that leads to the decomposition. So we'll assume that a collision is always necessary. Here's a nice visual here. We've got a diatomic molecule A, a diatomic molecule B. They're going to collide, and it's going to produce two molecules of AB. Now, here's what's got to happen. This little intermediate stage here shows it all. Are they colliding? You betcha. Are they colliding with enough force? Well, yeah, these big sort of bang marks are meant to indicate that. And are they hitting in the right locations? It seems to me that they are, because here's your molecules of AB all set to react. So they have to hit each other lengthwise, if you will, for a productive chemical reaction. And imagine how many collisions are not particularly lengthwise and would not be in the right position. So that little in-between time, when that's at the right position, enough force and everything, there's a transition state going on. Sometimes this is known as the activated complex. It's kind of interesting. It's not the starting material, it's not the product, it's that halfway in-between stage. Is this a good theory for predicting the rate of a reaction? Well, you be the judge, but consider this. Some reactions generate heat as they continue. They can sort of spiral out of control, and that has a big effect on the rate. And although a lot of reactions look very picky in terms of the way they have to react, there's a lot of reactions that are just plain fast, that even when you do the analysis, it would predict a slow reaction, and yet it's not. But it's an interesting thing to consider, how they need to combine in order for a chemical reaction to occur. That's a little bit about collision theory.